Okay, so in 4.7, we're focusing on modeling, and we're first going to talk about modeling exponential growth and decay. So they give us a formula for that right here. It can also be written as A of t equals A naught e to the k t. Now we've seen similar formulas before. I like the function notation a little better, but that's just my preference. A naught, that's the initial amount, how much you're starting with. Now, it could be in chemistry, it could be in all kinds of different fields. It could be in business. Anyway, E is E, right? So it's base E. This K here is a constant. Now, they're either going to have to give us the constant or a way for us to figure out what the constant is. T represents time. It could be in years, it could be in days, it could be in minutes, but it's going to be a unit of time, okay? So when we talk about A of t here, it's how much you have, so it's the amount after so much time. And that time is represented by t. Okay. So you can see this is an exponential function. It's got a base e, and then it's got that a naught in front of it. That's going to be a number, right? A constant. Okay, so characteristics of this function. It looks like well, not quite so pointed there, but something like that. It's a one-to-one function. Looks like an exponential function, right? It has an asymptote at the x-axis, so that would be a horizontal asymptote at y equals 0. Now go back to the equation we had. A of t equals A naught e to the k t. What happens if t is 0, like no time has taken place? Then you have A of 0 equals A naught e to the k times 0. Well, k times 0 is just 0, so you have e to the 0. But e to the 0 is just going to be 1, so you're going to get A naught. So this point right here is the point 0. Well, that didn't go nicely. That point is 0, comma A naught. It's gonna go through that point. All right. If k, so one more thing, if k is positive, if it's greater than 0, then it's going to be an increasing function, like the one I have drawn. If it's going this way, then that means k is less than 0. So here, k is less than 0, or negative, and then it is decreasing. It still goes through that point right there, 0, A naught. And there are no x-intercepts. Let me scroll up. There are no x-intercepts. By the way, the decreasing function also has an asymptote at the x-axis. And then the y-intercept, we know that, is the point 0, A naught. Okay. So, domain and range. Both of these have a domain of negative infinity to infinity and a range of 0 to infinity. So probably not a lot of surprises there because we've done exponential functions before. We've looked at their graphs. So probably not too much different than what we've already looked at, but good reminder.